Before I get started, I just kind of want to give a little overview of Aston. For those of you who don't know the company, we are a leader in software development as well as data and voice technology. We're located just across the parking lot here in the Parkdales. We're always looking for ways that we can help your business grow through direct services, or also we're always hiring talented data, voice engineers, as well as software developers. So, if you have any interest in any of that stuff or any of the stuff we go over today, don't hesitate to pull me aside or anyone else after the presentation. The way this presentation will work is I'm going to give a little talk, try to keep it around 30 minutes on building a simple iPhone app using a new framework from Apple called Swift UI. And then I'm going to hand it over to Jordan, who's going to do a really interesting talk on digital audio, and he's going to reconstruct a voice call from packet capture. So it should be really interesting. With that, I'm going to go ahead and get started with a slide here. So Swift UI, I mentioned it before, it's a new technology from Apple. And what's really unique and interesting about it is that it changes the programming paradigm. Typically, as developers, we used imperative programming, which is a very succinct and to the point and detailed way of programming. You are basically telling the computer every step to do and every state along the way how it should operate. Whereas declarative is a little bit more open and free. Swift UI is a reactive version of the declarative paradigm. And with this paradigm, what we're doing is we're telling the computer what we want the state to look like, and we're letting it manage the transition between those states. I've got a couple, maybe long-winded metaphors, but to kind of keep it short, imperative, you're saying, do this, go there, pick this up. And you're using, verbs of imperative mood. For example, if I were to tell you to go get groceries from a store, in an imperative model, I would tell you every step. You walk in the door, you pick up the cart, you go down the aisle, you reach on the third aisle from the left, you pick this product, you put it in the cart, you continue through, et cetera, et cetera, et cetera. All those different steps. In contrast, in a declarative model, I'm just going to show you the state of the cart, the empty cart before, and the state I want right before you go to the cashier, right? I'm going to let you, the shopper, or the program in this metaphor, determine how to move between those aisles, right? So it allows the program to be a little freer and adaptive, right? Perhaps they move products. If they move a product to a different aisle, the imperative model would break, whereas in a declarative model, it would adapt to that. So another kind of analogy would be if you're playing basketball, right? If I was trying to teach someone who'd never played basketball before, imperatively how to play, I would say, this is how you hold the ball, this is how you dribble, where you look, hold your elbow, how to shoot, all the individual steps and pieces of, say, running a play or shooting or passing and all that stuff. However, in a declarative model, I am just telling them that the ball needs to go through a particular hoop as many times as possible, and these are the rules to do it. And the rest of it is handled by the player, or in this analogy, the computer. So with that in mind, I'm going to go ahead and get started building a simple, quick iPhone app using Swift UI. So that's what it's going to look like when it's done. But we're going to start from scratch here and create a new project. So just a quick overview of this application. This is Xcode. It's a free development framework provided by Apple, albeit you do have to be on Apple hardware. There are ways to get around that. If you're curious, you can ask me after the presentation. This isn't just a 30-minute ad for Apple. So I'm just going to name it something here. And we'll get a little familiar with the interface. So what Swift UI allows us to do is not produce a kind of WYSIWYG or what you see is what you get editor, but instead to create things kind of programmatically in code and then see those in real time with what's called the, I didn't want to do that, the preview. So it defaults to an iPod Touch 7th generation. I don't know if anyone has that, but. So let's move to something a little more modern, kind of zoom it out a little bit. So this is what the basic app comes with, or a basic project starts out with. As you can see, very few files on the left, and inside here, a very simple view. So, and then on the right, you can see kind of the preview. The preview window is a little buggy, and it's been getting better, but it does crash out. And when it does, we have the simulator, which is pretty much as good as you're going to get without actually having a device. So I'm going to talk a little bit about the different structural elements now. So when you're building an interface, there is going to be some sort of order or structure. And Apple has reduced those down to 3 main structural elements. There's the Z stack, the V stack, and the H stack. It stands for Z for depth, V for vertically stacking, and H horizontally stacking. And with those elements, we can really create almost any view that we need. So I'm just going to create a little blue background for our interface here. As you can see, it kind of leaves the top and bottom areas empty. Those are what's called the safe areas. So you can easily override base views with these modifiers, and we're just going to forget about all of those, and you can see that the background then carries across throughout. Another really common element that you'll see is a text element. With that, it just simply shows a text on the screen. There are a lot of modifiers for the text element that are built in. Let's see here. We can make it a bigger size. Let's make it a title size. Let's change the color to white to kind of pop on that background there, right? So pretty straightforward. Let's create another text element here. You notice that it's putting it right over top it. That's because everything right now is currently inside of this Z stack. And even if I, let's make it size, just say like 16 or something, and again, make it white. It's not very readable. But what we can do inside of these stacks is you can nest stacks inside of stacks. So what I'm going to do is I'm going to create a V stack inside of the Z stack, which will allow me to vertically stack these 2 elements, one on top of each other, and we get more of the desired look of what we're going for. Pretty basic stuff, but there are a lot of elements like this that Apple produces or provides out of the box. One of those is image. Before I do that, I'm going to bring an image into the application. And you'll notice on the left here, there's just a few files. Info plist is just a property list. This is the entry point. And then there's this thing called assets. You can think of this as like a zipped folder of pieces, namely things like images. And I'll just drag. All you got to do is drag and drop them in there, and then they're available for the app. The different sizes are simply representations of different device sizes. So if you have an iPad or an iMac or something. I didn't mention, but Swift UI builds applications on any Apple platform. So that's from iPods to iPhones to pads, any device that you come up with. Another really interesting thing or convenient thing and powerful thing is that you can create color sets. So as you maybe have noticed, there is a color theme here at Aston. And that color theme is our brand, and with that we can create simple, let's see here, 28 colors, and then refer to those by name. I've called this one brand primary. We could have an alternative color for, say, a dark appearance and a dark background. So we'll go ahead and create another one, color set. Guess what color this is going to be? Green. I don't have these numbers memorized. They are on a Post-it note on my computer. So. Okay, so just a little bit of work. We've created some, themed colors, as well as it's pretty small, but not much to see there, as well as an image. So just with those few pieces in there, we can really clean up the look of our UI. So I'm going to add, as you can see, the previewer has decided to stop working for a second. Oh. An image should be somewhat resizable. We're going to make it as well the content mode, or aspect ratio, sorry. We're going to have it fit in the window. Come on. Well, we'll just switch over to the, build succeeded. We'll switch over to the simulator.
Buggy, you say?
Yeah, it does. It does not, well, it's catching up. It was doing well when I ran through it this afternoon, but I think all of you are making it nervous. So, so we'll just hop back and forth between this as it goes through. There we go. Okay, it's coming along. It's a little bit big. What I want to do instead of having it be full across the screen is I'm going to give it what's called a frame. So any of these elements, all of these elements are views, right? And all views inherit from a top-level view. So I can create views inside of views, and then every time I modify this, I'm actually wrapping it inside of another view. And that's what kind of gives SwiftUI its power. Let's see here. Let's give this a width. We'll just say 250 and 250, and it's already by default aligned to the center. So we can kind of see that it's coming along a little bit better. This isn't the same blue that we see here or anywhere. So we're going to change this default blue to our color brand. And that should clean it up a little bit to make it look a little more. It's hard to see with that black background, but that is the actual Aston blue color. So we've got a lot of stuff inside this VStack. This view is getting a little messy, or it's getting a little full. You're actually only limited to 10 or maybe 11 views inside of another view, but luckily it's very straightforward to create a new view. So these structs are constantly, we'll call this welcome view, constantly recreated and created again. So, and that's part of the declarative model. What happens is as the view changes or as pieces inside of the view change, the operating system constantly deletes and rebuilds the views with any kind of changing information. So we're just going to extract this. All views need to have a variable called body that returns some view, and we're just going to pull this stuff right out of there and pop it into our new view. Let's say that we wanted to maybe pass in a variable. We'll call this, what is this, logo, instead of having it always be. I would probably also create variables for the title and maybe that subtext as well. But right now, if we look, we're not going to see anything in the VStack, right? It's just going to be an empty blue screen, if it even runs. With the welcome view that we just extracted, we can simply create this welcome view and pass it the name of our logo. And we've created a new view. And we can collapse this, kind of seen everything in there. And with that, you can kind of build reusable components that will fit across the board. So I'm going to dive in a little deeper with a button. We'll just build a little button. And it's just going to print out something right now. Oops, that's all right. And then a button has a label, which just kind of gives it its appearance. Inside that, I'm just going to put a text. And we're going to say, I don't know, login or something that you'd find on a common app in the loading page. As you can see, it's pretty small, and it's blue in the background there. So let's give it a foreground color of white. Let's also give it a font size of, come on. So there are some pre-built ones inside of like title and subheading and caption, which are just preset sizes and weights. And now it doesn't look like a button, it's just text. I don't know where to click it. I'm going to give it a frame. And a typical phone frame has a width of about 240 and 40. And there it's going to be aligned automatically. And then now let's give it a background color. See, it's blue by default, which is the standard color by default. But instead, we're going to give it a color of, let's make it our secondary brand color. Secondary. And that will give it the feel of the theme that we're going with. Let's give it a little padding. So padding, if you apply padding, just basically it puts a set amount of padding around all sides. You can alternatively choose a left or right or top or bottom and adjust that in as necessary. And then let's give it a little rounded feel with a corner radius of 8. It's starting to look more like a button. Oh, it will in a second. Now in the preview window, what you'll notice here is that I've given this corner radius after I've given the background. So if we want to actually move this background above, that should give us more of the feel that we're looking for with a rounded green button. Nope. Did I do that wrong? Oh, we do want the frame first. So basically what I'm trying to show here is that the order that you apply these modifiers to the element matters, right? It's turning the color background of the text is green, whereas the frame comes in afterwards. So I thought I had that right the first time.
You want frame, corner, background, right?
I think so, yeah. Frame, corner. No, the problem is with the padding. Either way, we can put it here. So say we want to use this brand button over and over in our application. Well, simply we can create a brand button. What I name this doesn't really matter. And then we'll give it a title. And then we'll take the pieces from here, cut those out, paste them in, and instead use our brand button. And it's going to expect a title, which will say is login. Well, anyways, I'll keep going, and we can see it in real time as it decides to play well again. I want to connect this to an API so that we can actually access data from it. So what I've got here is an AWS endpoint using Lambda, which just is a simple JSON body that is returned. And if we look at this data here in a browser, we can see it's just got a few fields. And if I refresh it, it will show the time and some data. But most phone applications are going to want to talk to some sort of backend to retrieve data. And to do that, we need to make a call out. That's traditionally done over REST with an API call. So this dummy API that we've got set up, I'm going to try to call it from my application here. But to do that, we're going to, let's see what time is it here. We're going to create a new file. And I'm going to call it network manager. And inside of it, we don't care about the view. We're going to create a model that represents that. So I'm going to create a struct. We'll call it API response. It's got to be codable so that it can be decoded from JSON. And we're just going to simply mimic those fields that are in our last name. And then timestamp, I believe is what it's called. That's also a string in this case. All right, so now I'm going to move to actually creating the call. So typically I would use a library called Alamo Fire to do this, but it takes a little bit of time to import a library, a dependency, and so I'm going to use the built-in Apple URL session. We're going to call this final class network manager. And inside of it, this is a singleton class, so we're only going to want one instance of this. So I'm going to create a static instance of the class itself. We'll call it shared, which is a common practice. And this is going to be just a single instance of the very class that we're in. And along with making it a singleton, we don't want anybody else to create an instance of it, so we're going to make the constructor private. I'm going to create a URL variable that just simply is the string that points to TPS, demo.astontech.com, get data. That's just simply this endpoint here that I showed you before. Is there a simulator? Thank you, simulator. I know. So okay, so the button works. The border radius is in there. I don't know. I'll go back to it later. Whatever. now we want to create a function that's actually going to reach out to this endpoint, call that data. So, let's just call this load data. Now this is going to be a closure. So I'm basically telling it that I'm going to pass in a function that it will run when this function is called. So this is probably the most escaping. And then this is going to be a result. It's probably the most convoluted code, so I'm just going to gloss over a couple lines, which are moderately complex, but you'll understand what it's doing once we actually get it up and running. So I'm just going to say that when this function is called, I'm going to tell you what to do if you get a response or if you get an error. So along the way, and now we're going to create a task, and this task is just a variable that will, let's see here, URL session, data task, and it's going to be the URL that so that's this URL here. We're passing in, we're saying, hey, phone, when this function is called, reach out to that URL and see what comes back. So I think we get a response. No, I'm sorry. We get data, response, error in. Now, typically you would check for a bunch of stuff, like you would check that there's a 200 response, right? If there's not, let's just move on because it's bad data. We'd also check that the data is good, so check for good data. And by doing that, I'm simply going to assign it to a local variable. So guard let good data equal data. If it doesn't work, if something happens, then print error and get out of there, right? Because this bad data, nothing we can do, let's move on. So there would typically be a lot more error handling and checking. You would check to see if the URL was good, some other things along the way too, just to kind of make it more resilient. But really all I want to do is make the call, have it come back, deserialize that response into a Swift object of type API response. So now what I'm going to do is, you can see that, I'm going to try to, let's see, decoded data, and we're going to try to decode it. So we're going to try to JSON decode. There are a couple other libraries as well that you can bring in that in most of the apps that we build for our clients we would use, but for the sake of this quick demo, I'm going to use the Apple one. So when we decode it, we need to tell it what type of object to expect, and basically it's all saying that these field names need to match with these fields that are in the API, and then it knows exactly what to do with it. So we're going to say this is an API response of type self, so it's using reflection, and we want to take our good data and try to decode it. And if everything is good, then our success, completed, success, and we're going to pass in that decoded data. So what this is doing is it's simply calling that API, making sure that it's good, trying to decode it, put it in an object or a structure that represents this, and then pass it back. Otherwise, we'll just print error. I would definitely create more verbose errors if this was a real app. So we'll just say error decoding JSON. And then finally, we just need to task resume. So fairly complex syntax, but a little bit terse. And we'll reach out and call an API, and we'll put it into this response here. So let's put that off to the side and go back into our app. And so instead of just printing out to the console when the button is pressed, I'm actually going to call this network manager, shared, load data. Oh, the autocomplete in Xcode is also not helpful a lot of times. So if the data comes back, this is going to give us, we'll use this later, and then result. We are going to switch on the result, because the result's going to be one of two things. It's going to be successful data, or it's going to be an error. So we're going to switch on result, and in the case that it is a success, we are going to let whatever comes back, we're going to assign it to a local variable called call it API response. So, and then, we'll just print that out to the console. Nope, see, there's that autocomplete again. OK, and then we'll let the IDE fill in the rest for us. So if there's a failure, we're going to print the error. OK, so with this, we should be able to have all the pieces that we need to, when the button is pressed, it'll go off to our network manager. It'll call this load data function here. That load data function will then reach off across the API. Let's make that a let. To the API, and it should return the data, and then we will print it to the console. So there it is. Let's take a look down at the console, and if you can kind of see here, it actually does get the response back, and I'll hold for applause. So, like I said, it's a base part of almost every app, and fairly quick and easy to scaffold. So really the only other piece that I would like to show you is really dives into that declarative versus imperative model. So in the declarative model, I want to create some sort of object that holds the data. That's typically called a view model, right? So we have our view, our model. So our view is this thing right here, this content view. Our model is simply this base response entity with these fields. And a view model will be something that kind of sits in the intermediary. So I'm going to create I'm going to call this content view model, just because that should match up kind of with whatever view that you are using. And this is an observable object. So this is where the declarative piece really comes into play. So we're saying when this object changes, update the view with however those changes happen, right? So we're going to add some fields in here. Like, why is it showing that one? We'll say first name. Just initialize that to nothing. We'll get a couple more for our different pieces. We'll say, last name, and we'll call this one server time. And then all we're going to do is we're going to create a function. We'll call it load data as well. Doesn't pass in any arguments. And we're going to refactor this messy code. Because you can imagine having this code inside of every button is a bit unyieldy. So I'm going to take all this code here. Oops. We're going to pull it out, and I'm going to put it inside of this. Now that I've also done that, we don't know how long this will take, right? Don't know how long. Because it could take an hour, it could take a millisecond, right? And we don't want the rest of the view or the UI sitting there waiting. So there's a very nice way to push jobs off to a main queue and have that run, and then when the response comes back, it'll return to the view, and we can actually see that. So typically in, say, a Java application or something like that, you'd have to create a thread pool, you'd have to allocate threads, you'd have to assign a thread as runnable, and then catch it, and all that kind of stuff, and wait for it. But with Swift, it's very nice because we can just pop things onto this main queue and let it handle it. So we just need to wire our view model in here, again at state object. So these annotations, these at, published, observable object, at state object, these are the built-in mechanisms that allow for that declarative paradigm to work with Swift UI. So we'll just call this a view model, and it's going to be an instance of that thing we created above here, which is just a, content view model. And now, inside of here, I can create, the, load data. So if everything works correctly, we should see the same piece of information displayed on the console. There it is when it comes back. So what we've done is we've modified this. We just refactored the code out of the view into a view model, which not very exciting, but what it allows us to do, and what you'll see where the actual declarative piece comes into play, I don't want that. I'm going to use those first name and text view model last name. And then I think I called it server time. Nope. Okay, so if this runs, there will be nothing in those fields, and we won't even see them, right? Because there's nothing in the view model right now. These are empty strings up here. But instead, when we get our response, instead of just printing it, if we instead set the values from this response into the published values, so we're going to do self.firstname equals the API response, first name, and the same for the other two, API response, last name. And this time I've changed the fields a bit. I've called this one server time, but in the API, server time, in the API it is the timestamp. So with that you can change fields depending on where you are in the step. So this is our completed view model. I'll just go ahead and fold this up for a second. And now inside of this, when we run it, we won't see these text views down here, right? They don't exist. They're empty strings, so they're not rendered in the view. But I'm going to change the view model by clicking this login button, and then those fields will appear onto the view. So what you're not seeing is that the iOS in SwiftUI is destroying the entire struct view and rebuilding it back in every time anything changes, right? So as these fields and these observable objects change, the view is rendered and re-rendered for that. If they don't change, nothing happens. But if I hit this again, you can kind of see the time down there is the only field that's really updating. And this is a little funky, so let's put this in an H stack, right? The first and last name to make it look a little bit better. And with that, let's get rid of this preview. Now, when I do that, we'll see my corner radius, the kind of name left to each other. So those are the three structural elements, the Z stack, V stack, and H stack. With that, any combination, you can extract those into any other piece. For example, we wanted another button. Oh, this. Bum, bum, bum. It should be right here. Say we wanted another button. We could simply take this. Obviously, we would want different logic for when the button is clicked. But instead of title login, we could say sign up. And we would see the other button in place. Of course, it's going to do the same thing, but you can just see the power of those reusable components inside of SwiftUI. So that kind of wraps up everything that I wanted to cover. Not too bad on time. But what I wanted to do at this point is I'm going to ask a question. We have a Yeti mug to give away, so anybody who's been paying attention could potentially win that. What's going on here? Let's see. And then any questions that you guys have before I hand it over to Jordan for his presentation on digital audio. So I guess I'll kind of kick it off. Are there any questions about what I went over right now? Any thoughts or ideas? Anybody have $1 million app idea? You want to talk to me after this? I have my card. But okay, so while this is loading, can anyone explain to me the difference between imperative and declarative? Ooh, Yeti mugs. Oh, there we go, it worked. It says login though. Ah, because I forgot to change the title. There we go.
The analogy I was thinking of between the difference between them is imperative is like a recipe, whereas declarative is more like a salad bar.
Sure. Yeah, that would definitely work. You're telling every step in the recipe, right? Whereas salad bar, you're like, here's a picture of my Caesar salad. Go make it as you want. So yeah, I like that. We'll get the corner radius too, yay. Thank you. Cool. And so, to follow up that, which of those paradigms does SwiftUI use?
The declarative.
Yeah, very good. Sweet. Well, if there's no other questions, I am going to hand it over to Jordan at this time. So, yeah, please.
Is there a way, instead of destroying the structure every time and rebuilding it, is there a way to do individual elements like React.js does individual elements?
So you're talking about like the virtual DOM where it like diffs those two things. Well, there is a similar element or similar kind of mechanism under the hood in Swift that does that. It's similar complexity to the virtual DOM as far as it's diffing the changes between those things. But from my understanding, it's faster to rebuild them than to run that difference engine. So I'm not sure if that's primarily because of the device or maybe some hardware shortcuts that Apple takes with its kind of uniform hardware that you maybe can't take with a browser application or something like that. But good question. Yeah.
I'm kind of a novice, so I'm sorry if this is like a dumb question. I'm used to keywords like struct from C and
Yeah.
let from JavaScript.
Yeah.
So what language is this?
So this language is yeah. So this language is Swift, and Swift is built on top of Objective-C, which is kind of Apple's flavor of C. So all of Swift does get transpiled down to C before it's run. So the the assembler for whatever these chips are, Apple chips now or Intel chips, is a C assembler. So Objective-C, that's why you'll see carryover from things like struct, but then let and var are from JavaScript, and so Swift sits a little bit in between. There's a lot of similarities between it and say an object-oriented programming language like Java or C# or something, but there are a lot of modern functionalities that you'll see in something like Kotlin or some of these other more progressive languages. So there's a blend of that, but anything that you see here is actually compiled down to C, Objective-C, before it's run. That's what's run on the device. So, yeah, good question. Anything else? Yeah, Eric.
So let's say that your app is having a bug, right? And you have to go in and troubleshoot it. Would you actually go into that code right there, fix it, and then that fix would be released with like the newest version of that software?
Yeah. So what I didn't cover in here, which is almost a whole talk into itself, is the way that apps are distributed, right? Software is distributed however you go to a web, you download it. But apps, as you know, are going to come from one or two places. They're going to come from the Google Play Store or the Apple App Store. So there is an interface called, it's a web-based interface that you use to push your code up to it. I don't have it up right here, but there are tools in Xcode that allow you to build it. You basically build it for a generic device, and then you take that IPA, which is a craft beer and also an iPhone application, and that gets pushed up into the Apple App Store. You're very dependent on the App Store because there's a series of steps. It gets pushed up there. You can use it in Test Flight, which is like a tool that other people can. You could download Test Flight on your phone, and then you have access. I could provide access to an app before it's released in the store. And then when you're finally happy with it, you submit it for review to Apple, and then they pick it apart. There's very detailed guidelines, which I've had to go through several times, because if there's anything that they don't agree with, they'll reject it back to you. And sometimes they won't provide much insight as to why, right? So say our brand application here, we want to release it to the public. I would build it, submit it up to the App Store, fill out this form, create screenshots, an icon, all that other kind of stuff, and then submit it for review. And it could take anywhere from 2 days to 2 weeks. And they're either going to say, it's good to go, and then it'll be available in the App Store, or they're going to reject it, and you have to go through it again. So that's kind of the process of it. And if you're interested, I can show you how we do that with some of the production apps we build for like NPR or something like that. So cool. Good question too. Any other questions?
Does Apple own your applications if you make them in SwiftUI?
No. No, they do not.
Okay. And next question, is there an Android equivalent of SwiftUI?
There is. That's a really good question. It's called Jetpack, and it is maybe in beta now, but Jetpack Android. Jetpack Compose? Is it? So maybe it's just the Wi-Fi that's bogged down here. But anyways, yes, there is. It's called Jetpack Compose, and it does do exactly the same thing. It's a declarative mode of programming that replaces the Android Studio. Or maybe is it still an Android Studio, Jetpack Compose, or is it a whole new IDE?
It's just similar to what you're doing right now.
Okay. Yep. They are a little bit behind. I don't think. Is it released yet? Or?
I don't think so.
Yeah. So it's not quite released yet, but this switch of paradigms is pretty universal across the board, right? Like it's just a better and easier way to program as a developer. But that being said, there are a lot of pieces of the Apple. Man, come on. All right. Of the Apple Swift UI ecosystem that aren't quite built up yet, and you still have to revert back to the old UI kit way of doing it, or the equivalent would be Android Studio and Kotlin Java for that. Any other questions online? Or? No? Cool. JP, did you have a question? No? Okay. All right, so if the computer is not completely hung, which it is, we will move on to the next thing.